Let's do a brief demonstration to see what the impact of index overhead is as we add more indexes to a table. I have two tables in Oracle, Applications 1 Index and Applications Over Indexed. Both of these tables have a primary key, so that is one index for each. Then, on the Applications 1 Index table, I have one additional index, so that's two indexes total. On the Applications Over Indexed table, I have 10 additional indexes, basically one on almost every column in the table, and that makes a total of 11 indexes for this table. What I'm going to do is run this C# program, and it is going to insert 50,000 rows into the table that I specify on the command line. So we'll run this program twice to get results for both tables. If we scroll down, we can see that this program is just doing a simple insert. There is an implicit commit in the ODP.NET driver. Having this implicit commit is intentional on my part. I do want to run the test this way. I don't want to do a bulk load, like just selecting all of the rows from another table and inserting those into our two tables. Having that implicit commit is intentional. I'm trying to simulate a little bit better of what a program would do that would be running against a transactional database where you would be committing after every row and not bulk loading the data into the database. Also, we're going to record some metrics for each test run. If we scroll back up, we'll see that we're using a stopwatch here in .NET to get the total elapsed time. And then if we scroll down here to the bottom, we have a couple of helper methods. And we can see that the first one, we're going to get the amount of CPU time used by Oracle. And this is a value that will come back to us in centiseconds. That's 10 millisecond increments. That's the unit that Oracle gives us this value in the $stats table. Finally, we're going to get the number of blocks that Oracle's recorded as being changed. So we'll get an idea of the I/O impact of having more indexes on our table. So we'll go ahead and get these test runs underway. I will let you know up front, these do take a little bit of time to run. So what I'm going to do is I'm going to get the test run started. I'm going to pause the video and then come back. So what you're seeing is not real time, but there's really not much of a point of you sitting here and staring at a blank PowerShell prompt for a minute or so while nothing's going on. So let's go ahead and get the first test kicked off. We'll run the test that's going to insert into the table that has just the primary key and the one index to start with. Okay, there we are, it's finished, and now we'll go ahead and kick off the second test. Okay, and now the second test is finished. We can see we do have a discrepancy in the numbers. What I'm going to do is I'm going to transcribe these numbers onto a PowerPoint slide and then come back and discuss them a little bit. So here are our results. I've cleaned the data up a little bit. I've taken all of the values and converted those to seconds so that they're a little bit easier to read. And not very surprisingly, we see that the table that had 10 indexes plus the primary key, that not just took longer, that also consumed more system resources. And pretty significantly, there were quite a few more block changes for this table, again, which is something that we would expect with all those additional indexes to update. Now this data shouldn't dissuade you from having indexes on your table. Having indexes is fine. Just realize that there is a cost to your DML statements when you do have those indexes. And what you want to do, and we'll talk about this in the next segment, is you want to make sure that if you have indexes on your table that you're getting value out of those indexes, and you don't just have indexes that are there that you're not using, because those indexes are costing you overhead and you're not getting any value out of those indexes. So we'll talk about how to locate those indexes in the next section so that you can evaluate whether or not you really need to keep those.